This is day 13 of Advent of Cyber 2024, and this challenge is called It Came Without Buffering, It Came Without Lag. Wares are all about security. The glitch discovers that an app is illegally tracking the cars in Wareville. Not many car thefts in the city warrant such an extreme measure. He reaches out to McSkitty to investigate and identify how the application is tracking them and leaking users' positions. So the learning objectives are to learn about WebSockets and their vulnerabilities, and to learn how WebSocket message manipulation can be done. So for this challenge we need to start the machine, and we need to turn on the attack box. Introduction to WebSocket. WebSockets let your browser and the server keep a constant line of communication open. Unlike the old school method of asking for something, getting a response and then hanging up, WebSockets are like keeping the phone line open so you can chat whenever you need to. Once that connection is set up, the client and server can talk back and forth without all the extra requests. WebSockets are great for live chat apps, real-time games, or any live data feed where you want constant updates. After a quick handshake to get things started, both sides can send messages whenever. This means less overhead and faster communication when you need data flow in real time. So when you use regular HTTP, your browser sends a request to the server, and the server responds, then closes the connection. If you need new data, you have to make another request. Think of it like knocking on someone's door every time you want something. They'll answer, but it can get tiring if you need constant updates. Take a chat app as an example. With HTTP, your browser would keep asking any new messages every few seconds. This method, known as polling, works but isn't efficient. Both the browser and the server end up doing a lot of unnecessary work just to stay updated. WebSockets handle things differently. Once the connection is established, it remains open, allowing the server to push updates to you whenever there's something new. It's more like leaving the door open so updates can come in immediately without the constant back and forth. This approach is faster and uses fewer resources. WebSocket vulnerabilities. While WebSockets can boost performance, they also come with security risks that developers need to monitor. Since WebSocket connections stay open and active, they can be taken advantage of if the proper security measures aren't in place. Here are some common vulnerabilities. Weak authentication and authorization. Unlike regular HTTP, WebSockets don't have built-in ways to handle user authentication or session validation. If you don't set these controls up properly, attackers could slip in and get access to sensitive data or mess with the connection. Message tampering. WebSockets let data flow back and forth constantly, which means attackers could intercept and change messages if encryption isn't used. This could allow them to inject harmful commands, perform actions they shouldn't, or mess with the sent data. Cross-site WebSocket hijacking. This happens when an attacker tricks a user's browser into opening a WebSocket connection to another site. If successful, the attacker might be able to hijack that connection or access data meant for the legitimate server. Denial of service. Because WebSocket connections stay open, they can be targeted by DOS attacks. An attacker could flood the server with a ton of messages, potentially slowing it down or crashing it altogether. What is WebSocket message manipulation? WebSocket message manipulation is when an attacker intercepts and changes the message sent between a web app and its server. Unlike regular HTTP requests that go back and forth one at a time, WebSockets keep a connection open, allowing constant two-way communication. This is what makes WebSockets great for real-time apps, but it also opens the door for attacks if proper security isn't in place. In this type of attack, a hacker could intercept and tweak these WebSocket messages as they're being sent. Let's say the app is sending sensitive info, like transaction details or use commands. An attacker could change those messages to make the app behave differently. It could bypass security checks, send unauthorized requests, or alter key data like usernames, payment amounts, or access levels. For example, imagine a web app using WebSockets to handle money transfers between accounts. If an attacker gets a hold of the message before it hits the server, they could change the amount being transferred or even send the money to a different account. Since WebSocket connections happen in real time, these changes would take effect instantly without the user or server noticing immediately. This kind of manipulation can also lead to more significant problems. Hackers could inject harmful code or try to get higher level access. For instance, they might change a message to give themselves admin rights on certain malicious commands to take control of the server. What makes this attack so dangerous is that WebSocket connections often don't have the same security protections as traditional HTTP connections, like end-to-end encryption, which encrypts the request body of an HTTP request using JavaScript, using an AES key or RSA public key stored in the JavaScript file. If developers don't add vigorous checks like message validation or encryption, it's easy for attackers to exploit these gaps. By tampering with the data being sent, attackers can cause all sorts of damage from unauthorized actions to full system compromises. The impact of changing WebSocket messages depends on how the app uses them and what kind of data is being sent. Here's a breakdown of what can happen. Doing things without permission. If someone can tamper with the WebSocket messages, they could impersonate another user and carry out unauthorized actions, such as making purchases, transferring funds, or changing account settings. For example, if a WebSocket manages payment transactions, an attacker could manipulate the transaction amount or reroute the payment to their own account. Gaining extra privileges. Attackers could also manipulate messages to make the system think they have more privileges than they actually do. This could let them access admin controls, change user data, view sensitive info, or mess with system settings. Messing up data. One of the significant risks is data corruption. If someone is changing the messages, they could feed bad data into the system. This could mess with user accounts, transactions, or anything else that app handles. They could change things in real time and disrupt everyone's work in circumstances such as shared document or tool. Crashing the system. An attacker could also spam the server with bad requests, causing it to slow down or crash. If this happens enough, the system could go offline, causing serious downtime for users and businesses. Without good security checks, this kind of message tampering can lead to anything from unauthorized actions to the downing of an entire service. So, exploitation. We will be going to this web address, which is the IP address of the virtual machine for this challenge. So copy that, put that into your attack box, then we will open up Firefox. We will then go to that link, and if you're using the attack box on your browser, make sure to proxy the traffic of the application as shown below. So it wants us to go to the Burp Suite extension, select Burp, and if you see that dot here, it's enabled. So now open Burp Suite and navigate to Proxy, Intercept, Proxy Settings. So open up Burp Suite right there. Let's close that. With Burp Suite open, we go next, start Burp, and we will need to go Proxy, Intercept, then Proxy Settings when it loads up. So Proxy, Intercept, Proxy Settings, and in Proxy, need to find where it says WebSocket Interception Rules, which is right here, which seems to have been the default. We then need to enable the proxy intercept, which it already did. So we now go back to the browser and click the track button. So Burp will intercept the WebSocket traffic as shown below. So if we go back to Burp Suite, proxy, intercept, doesn't seem to be intercepting on mine. Do I need to click it off, turn back on? Okay, well, it seems to not be working, so we're going to get rid of the Firefox one. We're going to go, settings, and Burp's browser, and we will do allow Burp's browser to run without sandbox. We're going to exit, open up browser, which has now opened this one up, which should work with Burp Suite, and we'll now go to the site. But first, we need to turn off intercept because it's going to just track everything and block it. So now it's loaded, turn intercept back on, and then track. So with that done, go back to Burp Suite. We will see this. So to client, send this information, but then to server, it's sending this information. So what we should do now is change this to 8 and then forward it. So if we go back to the browser, okay, we might need to go back to Burp Suite and might need to turn intercept off, so it just continues. Nope, that didn't work. Okay, well let's go back to here and intercept on. We will now untrack. We'll click track again. We have this to server. Okay, that's the untrack. So turn it off, turn it back on. So just trying to untrack and track again to server. It's now only giving us untrack. Okay, so I needed to forward it more. So let's untrack and then click track again. Now we go Burp Suite. It's forward, and we just keep doing this until we get back to the one which is us trying to track again. Okay, just untrack and then intercept off, turn it back on. Now let's try track. So to server, change this to 8. Do I need to save it or something? So now forward. I'm just clicking forward a bunch. Okay, well nothing's working still, so let's turn off intercept. Let's untrack, refresh, and we finally got the flag. There we go. So we'll copy that, and we got flag 1, I assume. So manipulating the message. Following the successful identification of the WebSocket message manipulation vulnerability, Glitch continued testing for other ways to exploit the application. This time, he wanted to see if the messages posted on the app could be altered and manipulated. Is it possible to post using a different user ID? So that's for flag 2. And exploit the application and send a message as malware while capturing the traffic. Okay, so we're going to go to here, and we're just going to spam a bunch of letters, click send, which should then make its way to here. So forward, need to go through this until we find our message. Okay, let's turn that off. I can't bring too many messages. Now we'll turn it back on, and we will try send another message. So we've got this one, we'll send it as 8, and we'll continue forwarding, And that didn't seem to work, so let's try again. Okay, well, still not working, so let's just turn that off and restart the page. Now we're here, intercept on, send message, and send it as 8. So forward, now let's turn intercept off, and we can see there is the second flag. So let's send that, and that is all the flags. So if you like this video, make sure to like and subscribe.